Okay, we're starting with DMA80 today. We're going to be looking at sections 1 and 2. And DMA80, what we're working with will be radicals. When you see this particular sign, this is called a radical sign. In times past, you might see it and go, oh, that's a square root. We do call it a square root, but technically the symbol itself is called the radical sign. The number that goes up underneath the radical sign is called the radicand. There will be a value. If it's a square root, there's no number here. It's understood to be, but sometimes we have a cubed root, fourth root, fifth root. It could be a 25th root. The number that we write here to represent the root is, the name for that is called the index. So what we're going to do as we're looking at radical expressions, I'm going to start with how do we go about simplifying something. The simplest one that I'm going to begin with would be if I have a square root sign and let's say the number 25. The radical sign is here. There's no number, so it's understood to be a square root. When it's understood to be a square root, the understood number that we technically do not write is the number 2. That's why I put it in yellow, so you would know it's not normally written there. What happens is if we factor 25, we would get 5 times 5. In order for a number to come out from under the radical when the index is 2, that means we need a pair of the same number for that value to come out. So that would be a 5. If you have the square root, and let's say we had a -9. If you have a negative number with a square root, technically that would be -3 times 3. In this case, we have a negative number, we have a positive number. They are not the same. Since we do not have a pair of the same number, we're going to give an answer that's called not a real number. Now, right now, I'm telling you we can't get an answer for that. I don't want you to think I'm lying to you because I'm not. But when we get to, I believe, section 7, we're going to talk about something called imaginary numbers. So let me just give you a little preview. Section 7, when we talk about imaginary numbers, for right now, you would give an answer of it's not a real number. But later on, what we would do would be -1 times 3 times 3. We'd have a pair of 3's. That's going to come out. You will be told that the square root of a -1, we're going to call the letter I for imaginary. So that is going to come out as an I. Eventually, we'll factor it and be able to simplify that square root. But for now, as we're in the beginning section, when you have a negative with an even index, we're just going to say it's not a real number. But just so you don't think I'm fibbing, we will discuss and go into more detail in imaginary numbers later. If I'm trying to find the square root of 16 over 49. Now, right now, I'm writing these out longhand. I'm going to show you how you can do this on the calculator as well. 16 is 4 times 4. 49 is a 7 times 7. If I have a pair of 4's, the 4 comes out. I have a pair of 7's, the 7 comes out. Let's look at the calculator here. If I do second square root, I can then type in my fraction, and I can type in my 16 over 49, come out from under the radical. When I press enter, it's going to simplify and give me that same answer of 4/7. Generally, when you are working a problem, and let me do that square root of the -9. If I try to do the square root of negatives, notice it gives me error, a non-real answer. So if you do try to do this on the calculator, you're going to get an error message for that so that you know it's not a real number. So for a majority of your problems, if it's numerals, you're going to be able to key those in using your calculator. What if I were to have, let's say, x, the square root of x to the 6th power? What technically is happening here is that we would have under the radical 1, 2, 3, 4, 5, 6 x's. In order to pull out an x, our index is a 2 with the square root. So I have a pair of x's. That means I have an x that comes out. I have another pair, so a second x comes out. I have a third pair. So I have x, and I have how many x's? X to the third. In essence, what I'm doing is I'm saying 6 divided by 2 is equal to 3. Now, that might lead you into asking me the question, what if I had had something such as the square root of x to the 7th? What would I do there? Well, in this case, I would have 1, 2, 3, 4, 5, 6, 7 x's under the radical. 1, 2, 3 pairs. So just like a moment ago, I would still have x to the third that comes out. But notice, there is still a single x that's left over, so I would write square root x and still have a leftover x underneath. I know that's jumping a little bit ahead, but it's always a good teachable moment now to look at it. So 7 divided by 2 leaves me with 3, so 3 x's come out. 3 times 2 is 6, and when I take 6 away from 7, I have that 1 extra left over, so it's still left under the square root sign. Okay, let's look at a radical where we have something that is different than a 2. So let's take the 4th root of 16y to the 12th. When I want to calculate the 4th root of 16, there's 2 ways we can go about doing it. On the calculator, since my index is 4, I can press 4, math. I'm going to choose number 5. And notice it puts the index 4 here. And now underneath the radical, I can type in my number 16. So that's going to give me an answer of 2. The 4th root of 16 is 2. With y to the 12th, I'm going to say 12 divided by 4 leaves me with 3. 3 times 4 is 12, and there's none left over. So then that would be my solution. Let's say I have the cubed root of negative 27x to the 21st power. Okay, I've got the cubed root. So let's go to the calculator. I'm going to do 3, math. I'm going to choose number 5, the cubed root of negative 27. Now, remember, we could not have a negative when we had a square root, but we can have a negative with a cubed root. In this case, it leaves us with a negative 3. So that's a negative 3. And then with the x, 21 divided by 3, it goes evenly 7 times. You can have negative answers if your index is odd. So let's make note of that. If even index, you cannot have a negative answer. But if you have an odd index, you can have a negative answer. Because when you have an odd number of negative signs, it's always going to give you a negative. So you can have that as long as that value is odd. Let me show you another way to find if something is a perfect root. We're going to go to y equals on the calculator, and what we're going to do is we're going to type in the radicand divided by x, and where the exponent would go, we're going to put the value for the index. We're then going to do second table. We're going to press those keys, second table, and we're going to look for 1 in the right column. If there is a 1 we have a perfect root. So that number comes out evenly. If not, we are going to scroll up looking for first pair of whole numbers. When we find it, the value that's in column 1 comes out from under the radical. The value that's in column 2 is going to stay under the radical, and here you would still have the index. So I'll show you an example of that. So let's come back to the calculator, and we'll do the one with y to the fourth root of 16. So if I go to y equals, I'm going to type in 16 divided by x, and I'm going to raise it to the power of 4 because the root, the index was a 4. When I do second table, I'm going to look in this column, and if I notice here, there is a 1. To the left is the number 2. So 2 is the answer for the fourth root of 16. If I were to have let's say, the fourth root of 32, technically that's 2 times, hang on. Technically that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So with the fourth root, if you would notice, it takes a group of 4 for a single 2 to come out. So the 2 comes out, but under the radical is still left that single 2. So when I do this using the calculator, and I go to y equals, and I've got 32 divided by x to the fourth, second table. When I come here looking for a 1, there is not a 1. There's a 2 and then a 0.3. Once you go to where 1 should be, as you start looking up, you want to look for the first pair of whole numbers. That would be a 2 and a 2. The first 2 comes out from under the radical. The second 2 stays up under the radical. Let's say, for example, we had the cubed root of 120. Let's see, the cubed root of give me just a minute. 375. Now, I could make you do the prime factorization of that. If I did, you'd have 5 times 5 is 25, times 5 is 125, times 3 is 275. To simplify this, you've got a group of 3 5s, so that means a 5 comes out. And then under the radical, we would still have left the cubed root, and the number left underneath would be 3. So to do that on the calculator, I'm going to go to y equals, and I'm going to type in 375 divided by x raised to the third power. So 375 divided by x raised to the third power. Then I'm going to do second table. As I come down, this is where a 1 should be, but there's not a 1. As I scroll up and look for the first pair of whole numbers, this is my first pair. Notice the 5 on the left is the number that came out from column 1. The number on the right, the 3, is the one that stays under the radical. So the 5 came out. That was from column 1. And this 3 here was left under column 2. So this is just a nice shortcut that you need to know so that when you're simplifying, you will have that to better help you with these. And actually, my time is getting ready to stop. I'm at 14 minutes and 52 seconds. So we will stop here on section 1, and we will pick back up with section 2 next.